What's up, class? Mr. Wicklehouse here, and today we're talking about absolute value inequality. So you guys have done a lot of work with absolute value equations. We're just taking this up another level here. Alright. All absolute value inequalities create two inequalities just like the normal absolute value equations. So if you remember, when you're solving absolute value equations, it makes two separate equations. Same way with the inequalities. The little difference here is that the inequality will get flipped for the second equation. So it's kind of like multiplying by a negative. So for instance, if I have the absolute value of x is greater than 1, well, I'm going to create two new equations. One is going to be x is greater than 1, which is just what we already have. And then the other one's going to be x is less than negative 1. So when I turn this to a negative, it just flips the inequality around. Okay? So two inequalities. One is just like the original. The other one, we flip the inequality and change the sign on the number on the other side. Okay. So let's look at a few examples. Alright, so here's this one. So first thing I'm going to do is I'm just going to copy this down because that's going to essentially be one of my solutions. So x is less than or equal to 2. To do the second one, I'm just going to do x, flip the inequality around so that it's greater than or equal to negative 2. Okay? That's it. So the solution to this absolute value inequality is x is less than or equal to 2, x is greater than or equal to negative 2. Okay? Maybe I might want to write that solution in set builder notation. So if you guys remember, x such that x is less than or equal to 2 and x is greater than or equal to negative 2. There we go. Okay? Alright. Let's look at this example right here. So, I'm going to take this original one and I'm just going to copy that down. So, x minus 3 greater than or equal to 5. The other one then is going to be x minus 3, flip my inequality, less than or equal to negative 5. So same as the original, this one I flip the inequality and change the sign on the other side. Okay? Add 3 to both sides, I get x is greater than or equal to 8. Add 3 to both sides, I get x is less than or equal to negative 2. Okay? Alright. Let's say I want to do this one in interval notation. Well, this inequality is greater than or equal to 8. So I'm starting at 8 and I'm going to greater than, so to infinity. Okay. This one is starting at negative 2 and it's equal to, so bracket, negative 2 is going to negative infinity. There we go. And then just like what we talked about in class, for the warm-up we did in class, this set here and this set here have to be union together. Okay, because we've got this piece down here, this piece up here, we're skipping the stuff in the middle. Alright. We'll do one more example here, and I'll leave this last one for you to do, and we'll talk about it tomorrow. Alright. So just like with absolute value equations, we have to move everything away from the absolute value first. So I'm going to subtract 3 from both sides here, and I get the absolute value of x minus 4 is greater than 11 because I subtracted 3. Alright, now I'm ready to split this into my two inequalities. So I've got x minus 4 is greater than 11, same thing, and then I have x minus 4 is less than negative 11. Okay. Add 4 to both sides on this one. I get x is greater than 15. Add 4 to both sides on this one. I get x is less than 7. Okay. I'll leave it to you to think about how to write this in interval and or set builder notation. Alright. One more thing. We want to be able to graph these. So this says the absolute value of x plus 1 is greater than 0. So I'm going to write my solutions out. X plus 1 is greater than 0. X plus 1 is less than 0. Can't really turn this to a negative, but I'm still going to write my two inequalities out here. Okay. Alright, so subtract 1 here, get x is greater than negative 1. Subtract 1 here, I get x is less than negative 1. Graph it. Well, both of these are at negative 1. It's going to be an open circle. I'm going greater than negative 1, so this way. So it's all these. And less than negative 1, I'm going this way. So there's my graph and my solution. There we go. Let's look at another one. Let's look at this one. Alright, so got the absolute value of 2x minus 4 is less than or equal to 6. Okay, well, 2x minus 4 less than or equal to 6. And then we have 2x minus 4 is greater than or equal to negative 6. Add 4, get 2x is less than or equal to 10. Divide by 2, get x is less than or equal to 5. Okay, look at this one. Add 4, I get 2x is greater than or equal to negative 2. Divide by 2, I get x is greater than or equal to negative 1. Do our graph. Got 5 up here. Negative 1 down here. They're both equal to, so I'm going to put my dot and fill it in. Put my dot and fill it in. This one is less than or equal to 5, so this is going this way. This is greater than or equal to negative 1, so this one's going this way. I'm doing the arrows like this because really I'm mostly concerned in my solution is where these two things are overlapping. So they're not overlapping on this side, they're not overlapping on this side. Instead, they're just overlapping everything between negative 1 and 5. So that is my solution set right there. Negative 1 to 5. Okay? Alright, let's look at this one. Now this says the absolute value of x is greater than negative 3. Alright. You might remember that when we saw the -3 with the equations, that we would say there's no solution. But with this, it's a little bit different. Okay? So, what we're going to do again, x is greater than -3. Then I flip my sign and change my sign. So x is less than 3. Alright. Graph it. I have 3 here, -3 down here. Greater than -3 is going this way. Less than 3 is going that way. These are not equal to, so the circles are open. And it's everything in between, just like on this one. Okay? This one I'll leave for you to think about. Remember, you have to move the stuff away from the absolute value first, and then you'll be able to solve it and graph it. Alright, that's all for that video. I'll see you guys in class.